Okay, this is Paul Gregg. I'm going to make another video about the Speedy Coaster, except this is more directed toward um, the Air Force um, that really want to explore this high-speed uh, roller coaster, high G roller coaster, um, as a means of um, pilot training and high G maneuvers. Uh, Kind of the idea that it's better than a screen-based flight simulators in a lot of way, and it's better than a centrifuge high G trainer. And so I made a previous video that went over this as a kind of a commercial venture uh, for high speed, um, high high thrill roller coaster, really a single rider high thrill roller coaster that would be used by private individuals or some place that really wanted to do that, where normal people, regular people can't really ride it. Um, so um, this is the concept: a high-speed, high G single or double rider roller coaster used to train fighter pilots and astronauts with clear performance advantages over high G centrifuge and screen-based. Even the tilting simulators, they really lack as far as really feeling the proper accelerations. And so that's the idea. And this is more based towards someone who really thinks as a training um, simulation. This is about me. I worked in aerospace for 34 years. I worked in backyard roller coasters after I retired, and and it kind of led to this that, hey, why don't we make a really fast, a really high G roller coaster? And speeds would be lower, but the turn radius smaller, so you can get the high Gs and use hub motors. This is a real innovation, is that you take skateboard technology that has hub motors, you put it on a roller coaster, and so you don't need a lift hill. You just the whole track is kind of low with high banked angles, and you don't need a lift hill because the you press on a pedal and there's onboard lightweight batteries, and all the wheels that contact the track are either accelerating or braking electric hub motors. And we know that in the past 30, 40 years, the tolerances for roller coasters have gotten much better than they were when flight simulators were originally envisioned. And so you can have a really fast roller coaster, and there's a bunch of companies that know how to make this. Um, if you want to do high G simulation, and I did talk to a fighter pilot, Scott Brazelton. He bought my books and made a backyard roller coaster for his son, and quite famous on YouTube. And and I talked to him, and he had some good input on that what the pilots would really like is uh, a simulator that they can control everything, not just the one I'm proposing. You can control the speed, and so the G's are a little higher, a little lower, but basically you can't turn anywhere you want. You have to go where the roller coaster is telling you to go. But it would be much safer and simpler and cheaper than having pilots uh, fly. They still need a lot of flying time, but as far as the simulator time, this could be a less expensive alternative and a better alternative in many ways. Uh, I talked about the advantages. In a centrifuge, you just have high G's in one direction, and they see if they black out, and uh, and that's useful training. But this could be, you turn left for so much time, and then you go straight. You turn right for a certain amount of time, and each track would be different. And you do negative G's or positive G's. You can do a loop, a roller coaster loop, and put a lot excessive positive G's for as much time as you want if the roller coaster was designed that way. Um, it would have less motion sickness as the simulators have they don't have a good spatial frame of reference. It's not a digital representation on a screen. It's real life. It's a real roller coaster going into a turn, and I think that you'd induce a lot less motion sickness. In the case of a gray out or blackout where the pilot, his brain is not getting enough oxygen, even if even then it could put his foot off the accelerator and decelerate. This would be safer than a centrifuge because a centrifuge you're spinning around and they have to takes a while to slow it down. So track architecture, you could have the traditional three-tube welded steel truss, or there's new manufacturers of good roller coasters that are using welded box beams and welded I-beams. And I don't know the tolerances. I know these are all very secret to these companies, how they build these things. And that's really where the development work is. But any one of those could be used for this uh, speedy coaster type of flight simulator. The technologies that are needed, need good, really good track design and analysis, sophisticated enough to do the three-dimensional dynamics. And if that's one of these programs, I'm sure the big roller coaster companies, the good ones, have their own proprietary systems for that, and you could tap into that. Track fabrication, the bending of the tubes and all of that has to be very precise, and there's different companies that can do that. I would not invent that myself. I just use what's out there because there are 129 mile an hour roller coasters, and I'm not proposing to go that fast, and so the tolerances are probably already there. And then the lightweight batteries on board, and there's a lot of battery technology come online in the last 20 years that could be used, and hub motors, um, similar to skateboard motors. And I want them to be so you could brake with them as well, regenerative braking. And you could also have a safety brake system involving grabbing the track or something like that in case you really wanted to stop quickly. And then the controls for safety. So let's look at what a fighter jet does. This is a thing I found online for F-16, F-15, and F-14s. This is how fast they can turn. Um, they can do roughly 14 degrees a second, and it's a huge turn radius. So to get that same acceleration, you can do it going a lot slower if you just make the radius a lot smaller. So um, the equation is pretty simple. Acceleration is v squared over r, the radius of the turn. Uh, Velocity squared divided by the radius of the turn. That's the centripetal acceleration. Um, 35 miles an hour, not very fast, 15 meters per second. In a 6 meter turn, the centripetal acceleration is this equation, 81 meters per second squared. That's 8.2 Gs for as long as you want if you do a spiral. And so it's pretty easy to get really high Gs, and you don't have to be that big. So this is a lot smaller. Yeah, um, the turn radius is just a lot smaller than a real fighter, but you can spiral it and get, if I wanted 8.2 Gs for 10 seconds, I just make some spirals and however many it took to do that. This is optimum bank angle calculations, and I found this online, and it seems to work good, and I use it. Whatever speed you're going, and whatever radius of turn you're doing, this will tell you the optimum bank angle. And of course, when we're going relatively fast and a small turn radius, we get really high bank angles. Okay. Uh, 5 meter turn radius at that speed. What speed was this? 13.4 meters per second. 80.7 degrees, really high. So this is a table that I made up. And if you were going these speeds and you were turning in this radius, this is the centripetal acceleration, which is the simple calculation, and this is that divided by 9.81 meters per second squared to turn it into Gs. We feel 1 G when we're sitting on the Earth, level, and this is how many times uh, the force of gravity you feel. So um, if I was going 80 miles an hour and I wanted 9 Gs, I could make a turn radius of 14 meters. And that's a, you know, reasonable size track. Optimum bank angle, 84 degrees. And the number of spirals to get the same duration, I'd have to do almost 6 spirals to get the effect of what the fighter does in the same amount of turning to turn 180 degrees. And uh, but down here, just pick any one of these. If I was going 50 miles an hour and I had a 5 meter turn radius, I could get 10 Gs, and I'd have to go 10 spirals to do, you know, the how many seconds there? Um, I'd have to go about 7 seconds, I guess. So you can look at that. So the proposal is we find uh, an Air Force entity or DARPA that's interested in developing this, and we get with one or two or more. We make some proposals to roller coaster companies and say, look, we want a prototype. Let's do some time worth of designing, analyzing, building a prototype roller coaster that really does go to 12 Gs if we wanted to. Build a track, do some testing, sort out the motors, sort out the batteries, sort out the braking, the controls, and phase two, go to a larger system and let pilots try it out. And so I think contacted a few companies, and we'll see what happens. But that's basically the concept, and I think it has some viability. What I'm looking for is someone to tell me this is not a good idea. Tell me the reason this is not a good idea. You know, it's in many ways better than a screen-based flight simulator. In some ways, it's better than a centrifugal um, high G simulator. It's kind of in between that, and I need someone to tell me why this is not a good idea. And that's basically where I'm at today. Thanks.